should we talk about the activities of the European Environmental Agency?
Good evening, everyone. I know I'm between you and dinner, so don't worry. I thought I'd do two parts. This is a bit of an update on what we were asked for and what's going on at EEA, the European Environment Agency. But I thought maybe just have a little reality check on what happens when things get to WG Chemicals. It follows on quite from what Stephanie was saying about how it sort of fits together. So just an update. I'm going to talk a little bit more about these, but IPCam, human biomonitoring, a bit on the Water Framework Directive and where we got to with the RBMP reporting. I won't detail it, but we're starting a chemicals assessment with our topic centre, and they're very pleased to have Rolf and Ingo on board, and that's great, and that starts later this year. And we've also just the topic centre with Just van den Ruwaard at Deltaris is just finishing an emissions report, emissions to water, where he's really gone into detail on the EPRTR data, and really with a focus on where we can get it on the priority substances. Mainly that's about metals and nutrients, but we do have some data on that. That's going to come out quite soon, and it's meant to be a data resource. So, IPCam, we heard about that earlier on. Xenia, my colleague, is leading on this at the agency, and we heard about the detail, but EEA has a leading role in this in terms of coordinating the environmental monitoring data and human biomonitoring data. And there's a real plea to get data or metadata into IPCam. I think that's Xenia's very happy to talk about that later on. And then also we're working on the strategy for a non-toxic environment. We've heard a bit about that again today. This EEA is starting on this area of work, really involving mixtures, and Xenia's quite keen to get involvement of science into this area of work. Yeah. Okay. So we're to say the chemical expertise at the Environment Agency is developing. It's been quite small, but actually it's a growing team. And in particular, the human biomonitoring project, which you heard about earlier on, EEA is a partner in this, and we've got it's a big program. There's about 100 partners, and the Environment Agency it's got a mixtures component, which this doesn't deliver until 2021, but it's really looking at mixtures from in terms of a receptor, the humans being the receptor of the mixtures. And this is the package that has been led by our IVM, and you can read it. But Catherine Gantz-Labine is the leader on this task, and it's sort of using mixtures to focus in on what matters as the receptor. Okay. So RBMPs, I feel a bit more comfortable, I know a bit more about this. I'm going to show you, so this is the countries have been reporting their data slowly, because it was quite difficult for them to get the data into the system. And we've got some preliminary data on chemical status. Now I'm going to show you two sets of graphs. Some of them are from very recently, with 11 member states, and this is earlier with 7 member states. And what we see is this is good, good status, pretty well good state in this coastal waters. This is chemical status, by the way. Rivers, transitional waters, and lakes. And the lakes is this bit here. This is Finnish lakes. It's dominated by Finnish lakes, which are failing for mercury. Okay, so this is just a similar thing, but with area. The big sort of improvement compared to the previous set of reporting is there was an improvement in unknown status. So that's what we're getting at. And then again on these 7 member states, we had a quick look at what's being reported or what's not being reported. This sort of grey area is how many lake waters, river waters, transitional waters, coastal waters. So the more grey, the more types of water that are being found in. And just to sort of get at this time, this was the leaderboard, okay, into traditional nasties. Okay, there's not that many surprises there. We're not now, whether this is owing to monitoring or what countries look at, or that's genuine the substances of concern. That's a question for debate, but that's what is being found. So mercury being found in a lot of places. Germany haven't reported yet, but Germany are failing everywhere in their plan. Belgian rivers are flailing everywhere for mercury. And so this is, there we go. We can't go into interpretation too much because we haven't got enough states yet. At this point, these substances hadn't been reported anywhere as causing failure. Okay, so that might be considered a bit of success for source control. And this is the most recent data that I've got so far. So here's rivers, lakes, coastal, transitional, numbers of water bodies. So rivers, we've got 25,000. 10% failing good status, 10% we don't know. Most of those are in France. Still, we've got the lakes issue. That's probably going to continue, and that's mercury. There we go. And a quick look at the RBSPs, what's failing it again. There's a couple of surprises in there, but here we go. It's the zinc copper. What matters here, because obviously we haven't got a standard set of RBSPs, because countries can select their own, select the substances which are a concern to them. So it's not like priority substances where you can say that's definitely, they've all looked at that. So what we've got is zinc and copper, then we've got ammonium, and this is turns out to be, it's the Netherlands. So, and then fewer countries reporting this, and then we've got arsenic. Has been quite a concern, and that's interesting actually because the EPRTR results are showing arsenic as being a bit of a problem. But again, we're not doing too much analysis yet because this is quite early in terms of we're waiting for 28 member states, or certainly quite a few more than we've got already before we can go too much analysis. Okay, I thought I'd have a little bit of time. So, what can we learn from past efforts to bring in scientific progress? So we get some really great science presented to the working group chemicals, but that's not the end of the story. There's all the effort that the science, if you like, solutions, goes into getting the science to the point where you can start thinking about operationalising it. And then it hits working group chemicals, okay? And I just thought, what's actually gone in over the last few years? And I think this is the list of what's got in as opposed to what's been talked about. So there's mixing zones, and mixing zones, that's where the discharge goes into the water, and at the point of where it meets the discharge with the water, the river water, whatever, it's probably exceeding the EQS. And the guidance says for how long that's acceptable. Okay, that's something that most countries were doing as part of their permitting procedures before EQSD came in, the Environmental Quality Standards Directive. So that was set up there's very specific mention that in 2008 Directive Article 4. I think that took 2 to 3 years to get the guidance through working group chemicals. Statistical approaches, again, it was sort of hidden away a bit in the 2008 Directive. This is I'll show you that in a minute, but it's basically, if for a given confidence level you're meeting the standard, if you sample more times in the year, you might expect to have more failures just because you've checked it more often. And have you necessarily failed the EQS? So that's might feel fairly contentious, but that took quite a bit of effort. Bioavailability metals I'm going to talk about again. Again, it's sort of a bit hidden away, but it's in the directive, the new directive. Pharmaceuticals, most of you know the story. That actually, the science wasn't the issue with that. Those substances. It was more about the socio-economic discussion. And then biota standards. Biota standards are in the 2008 directive sort of in an oblique way. So mercury's in there, HCB, HCBD. But a much more challenging version of the biota standards are in the 2013 directive. I think that's going to be quite challenging for member states to deliver on that, but we'll see. So statistical aspects of monitoring doesn't seem that it would be particularly contentious. It took a lot of effort, several workshops. I think it took 2 to 3 years. So we had some workshops, or my predecessors had workshops, explaining, capacity building, really working with the working group chemicals to explain. And so here's a range of countries that were involved. Just to explain the working group chemicals, you've got quite often officials, and you've got technical experts. You've got a mixture of people, and they're just the representatives of their country. Okay, and I say that and I mean that in the sense that they've got to communicate and persuade, often, funders in their countries, workers in their countries, people who are out there in the field doing the work. They've got to get all this communicated. There's a long, long chain of things to happen. Okay, so this is why, they've got to really understand and be able to persuade and get the influence that this is something useful to do. Okay, so you think that wouldn't take too much of it. It took quite a lot of effort. Bioavailable metals, so this is saying you can go and measure the metal concentration, but is that actually a toxic? What's the toxic portion of that? And there were some countries that were very, very keen to investigate that because they didn't want to be failing the EQS and being expected to take measures where actually it wasn't a problem. And conversely, you don't want to be missing places where you should be taking measures because actually there is a problem. I looked back and the activity started in 2011. Right, now this is based on a really quite complex, robust scientific model. And it's had quite a lot of support from the Eurometaux, the metals industry, to sort of financial support. Started in 2011, there's workshops, there's explanations. The model was condensed to sort of make it more accessible for countries to use. Things like reduced to what was excess to countries to measure was pH, DOC, and calcium, and that's what was. And the team spent quite a lot of effort, and are spending a lot of effort to make sure it's adaptable for all different sort of conditions you might meet in Europe, sort of 95% of the environmental conditions. And it's workshops, and it's discussing and coming to working group chemicals. And here we are, 2016, December, there's another activity to get it in still, because although it is actually formally in the 2013 directive, it's still difficult for member states to implement. Okay, so I'm just illustrating that because I think solutions is more ambitious. Okay, it's more ambitious, and I don't want to be bearer of bad tidings, but this is the scale of it. Okay, this is it's really ambitious, and so developing the great product that gets from solutions to working group chemicals is part of the story. It has to be robust science. But then there's the next effort. Okay, and just looking at those examples, I thought, what's it taken? It's taken effort. Okay, it's taken the science there, but then you get to working group chemicals. And what that means is it's countries really being able to operationalise it. So if you need country leads to say, yep, we're going to work with the experts on this. We're going to show other countries how to operationalise things. That's what it takes, and it's having people who are experts, researchers coming in and sort of saying, look, this is a really great technique. That's nice. It's nice, but it doesn't say this is possible and you're achievable and you can do it. And by working with some countries and persuading them to work out and find some of the problems and pilot it and really show that it can work, that's how it gets through. Obviously you need DGM to think it's a good thing because that helps it in the sort of, especially if you're looking at getting the legislation in place. But it really, what it does, it's not a fail-safe to get a country over there, but I'm fairly sure it wouldn't get through if it didn't have countries helping you. And just in terms of solutions, we're not there yet, but that's the sort of the way to be thinking about it. And if you're thinking about that's where we need to be, I'd say that's be priming friendly countries now, because you're going to have to be warming people up. Legislation gives a weight, but it's not a guarantee that will be implemented. I say that because I was thinking about Mercury and biota, which was in the 2008 directive. A lot of countries didn't do that. It puts them into compliance issues. But countries said we can't do it. We can't. We do water. We can't do biota. Or we haven't got biota. Or we haven't got. So although you might have legislation, but the countries have to really think we can do this. Helped by basis and familiar methods. What I meant by that was the mixing zones, something that countries were really already familiar with. Helped, and also capacity building. So think about the supply chain of who's going to be doing this. It's a long way. So actually getting countries on board and training them up to do things. Now, that's not all solutions work, but that's the sort of effort I think that was required. That's all I wanted to say. I think we're near dinner, so I just thought I'd leave you with this thought, but not really answer it. Anyway, thank you.